Functions. The first lesson is on functions, all right? Functions are probably one of the most important things you can know for pre-calculus because you need them in calculus. A lot of calculus, hey man, almost all of calculus is based on functions. So you really need to know your functions. But forget the calculus now, we're on pre-calculus. If I had to come up to you right now and I said, hey Sam, what is a function? Would you be able to tell me? I don't know, man, think about it. If an 8th grader or 6th grader had to come up to you right now and say, hey, what is a function? Can you define a function for me? Will you be able to do it? Now, when I asked myself this question a couple months back, I couldn't do it because I didn't know the definition of a function. Instead, what I did was I said a function is y is equal to 2x plus 5. That was my function. And I wasn't wrong. That is a function. That's a linear function. But I didn't give you the definition of a function. It's like me going up to you and saying, what is a vehicle? What is a car? Can you explain to me what a car is? And you say, a car is a BMW M4 competition. You're giving me an example of a car. You're not telling me what a car is. The same way I'm giving you an example of a function, I'm not telling you what a function is. So, Sia, what is a function? What is the definition of a function? Let's take a look at that right now. Definition of a function. A function f is a rule that assigns to each element x in a set A exactly one element called f of x or f at x in a set B. Now, what does that mean? Okay. Oh, by the way, before I forget, I'm sorry about this glare that's over here. It's because of my lights. I have to find a better way to position them. This glare, there's one here, and there's another one here. But I'll try and write in a way that it doesn't affect your eyes. That's why I chose this spot. But I'm sorry, I'll fix it later if I can. All right. I'm not really a lighting guy. But anyway, that definition. A function f is a rule that assigns blah, blah, blah. The definition you just read. If you do not understand the definition, perfect. Okay, perfect. Because I'm not expecting you to understand it. Okay, in fact, I don't want you to understand it yet because I have to explain it. Okay, so it's okay. The reason I showed you that definition in the first place is because I want you to know where we're heading. Okay, but if it didn't make any sense to you, that's okay. I'm about to explain it to you right now. I will get to the definition of a function later. We'll get to it. But first, I want to explain to you a function in a way you'll probably understand. This is the way that I use to understand it, and I think you will understand it too. I will not be doing much explanation. Instead, I'll be doing a lot of drawing. Give me a few minutes. I need to figure out how to draw a vending machine. Okay, now this is a vending machine. I know it doesn't look like a vending machine, but I tried drawing a vending machine, okay? Now, this is how functions work. I'm going to explain it to you. Forget about the definition I read for you a couple of minutes back, okay? This is how functions work. A vending machine. When you go to a vending machine, now, okay, let me explain my vending machine quickly. This is Coke, so it goes with this one. I put some red there to highlight it. Coke, it's this button. These are buttons, okay? Pepsi goes with the blue one. Apple is for Apple. JB is for Jeff Bezos. This is Jeff Bezos, okay? Mr. B, that's Mr. Beast. Bad Bunny, this is Bad Bunny. Okay, so the buttons correspond with the pictures. Now, see, how does this explain functions? When you go to a vending machine, okay, and I hit the Pepsi button, boop, on that Pepsi button, what is going to come out of the vending machine? Pepsi. I'm never ever going to be able to hit the Apple button, boop, and all of a sudden Bad Bunny comes out. Not gonna happen. Or I'm never gonna hit the Coke button, and instead of the Coke button coming out, the apple comes out. That's not an example of a function. Each button corresponds to whatever's in the vending machine. Okay? So even if I covered everything up here, I removed everything. I covered it up, I can't see it, my eyes are closed. If I read a button that says Pepsi, and I hit that button Pepsi, I know what's gonna come out of the vending machine. It's a Pepsi. The same thing with JB. If I hit the button JB, then Jeff Bezos is gonna come out of the vending machine. Okay? That's an example of a function. Basically, what I'm saying is, for every input, there's only one output. For every input, there's only one output. What does this mean? It means I can never press Apple and get an apple and a Pepsi. Cannot happen. It cannot happen. Once that happens, that vending machine is broken. It cannot happen. Think about it logically, all right? You see a vending machine somewhere down the road, okay? And you decide to hit the Apple button. And instead of getting an apple, you get an apple and a Pepsi. Now I know that's a steal. I know you might be happy for that, but that's not a function. It's not how the machine is supposed to work. It's supposed to give you an apple when you request an apple. Okay? So what if you press the Apple button 3 times? What's gonna happen? You're supposed to get the apple 3 times. You're never gonna get an apple 2 times and Bad Bunny once. Yes, it's 3, but that's not a function anymore. That is not how a vending machine works. Okay? Now, there's something I need to specify here. There's something you need to know, okay? I explained to you that one input has only one output. Coke button gives me Coke. Pepsi button gives me only Pepsi. Apple button gives me only an apple. JB gives me Jeff Bezos, and so on. One input, which is me pressing the button. One output, Jeff Bezos coming out, or Bad Bunny coming out, or Mr. Beast coming out. Okay? Now, it is possible that my input is not one, but multiple inputs. I'll give an example. Say there's a slot somewhere here where you can put in a coin, all right? Now, I have a coin. Let me go get it quickly. All right, here we go. I got a coin here. It's probably not something you're gonna recognize because this is a South African coin, but I have a coin. I pop the coin in there, boop, goes in. That's one input. Me putting the coin into the vending machine is an input. And then I hit the button, Apple. That's another input. So how many inputs? There's 2 inputs. But what's the output? Still 1. Only one output. Now, does that make sense? Yes, it does make sense. When you go to a vending machine, you first have to pay. You're never gonna hit a button and then you get what you want. You first have to pay. So that's me paying now with the coin. Boom, put it in the vending machine. I press Pepsi. Now there's 2 inputs, me paying and me pressing the Pepsi button. And you know what's the third input? The start button. That's another input. Because I can put in the coin, I can press Pepsi, but if I haven't pressed the start button, nothing's gonna happen. Now, of course, vending machines are built different, of course, but in my case, my vending machine only works if you press the start button. So how many inputs? 3. But how many outputs? 1. That's still an example of a function. You can have multiple inputs, but the output must always be one. Or you can have one input, okay? If we remove the slot here, and we remove the start button, say it's a free vending machine. Say someone decided to put up a vending machine for free down the street. So you can just go and press a button and you get whatever you want. Now, if I saw that vending machine and I had to choose something from this vending machine, I would choose a Coke. I don't know about you. Maybe you choose Jeff Bezos. Okay, I don't know, man. But I'd choose the Coke. That's still a function because I pressed the Coke button and input, and I got the Coke out. One output. But most vending machines don't work that way. You first have to pay. There's me taking my coin, putting my coin in there. That's my first input. There's me deciding what I want. Oh, I want Bad Bunny. Boop. Bad Bunny comes out. There's Bad Bunny. One input, one output. Or multiple inputs, but still one output. Function. That's an example of a function, okay? Let me put Bad Bunny back where he belongs. Now, let's add one more, okay? Let me add another option here, down here. Now, I don't have a picture for this one because I didn't plan it. It just came in my head now. But let's say this is Bad Bunny's brother. Bad Bunny's brother. Does Bad Bunny have a brother? I don't know, all right? But let's say Bad Bunny has a brother. Let me try and draw his brother over here. That's Bad Bunny's brother. And his name is, where can I add his button? Let me add his button somewhere next to JB. His name is GB. Good Bunny. His brother is Bad Bunny. His brother is Bad Bunny. That's Good Bunny. Let me put him a smile there to show him that he's a good bunny. Okay? Now, if I press GB for Good Bunny, what's going to happen? Good Bunny is going to come out of the vending machine. Not his brother. Yes, they may be related. But GB, sorry, Good Bunny doesn't want to stay now. See, his brother came. Now he wants to leave. I don't know what the issue is up with them. Siblings, you know. But anyway, GB for Good Bunny comes out. Bad Bunny button, Bad Bunny comes out. One button for everything here. So to summarize it, I want to keep repeating the same points so you get them, okay? If you don't get this vending machine example that I made, just think of a vending machine maybe you've used before. You'll get it, okay? You'll get it. Maybe my vending machine doesn't make sense because I had to draw it, you know, I had to put some messed up buttons over there, but it's a vending machine. Just think of a vending machine, okay? So again, can a function, now that's a question for you now, can a function have multiple inputs? Yes, it can. Why? Because I go to a vending machine, I have a coin, I put the coin in there, that's one input. I press the button, that's a second input. Maybe there's a start button somewhere here, start. I press that start button, that's 3 inputs. But how many inputs am I gonna get? 1, the apple. If I press the Coke, then I'll get the Coke. If I press Mr. Beast, I'll get Mr. Beast. So multiple inputs and one output, function. One output, one input, function. You cannot have multiple outputs. That is no longer a function. Okay? Now, why can you not have multiple outputs? Not inputs now. Outputs. Why can you not have multiple outputs? In order for something to be a function, it needs to give us one output, which means we need to depend on it, which means if I get an answer today, that must be the same answer I'm gonna get 50 years from now. I cannot get x equals 5 today and get x equals 9 tomorrow from the same thing. No, that's not a function. That's like me pressing the Pepsi button and I get a Pepsi, but the next time I press the Pepsi button, I get a Coke. And the next time I press the Pepsi button, I get Bad Bunny. Doesn't make sense. It needs to be reliable. Every time I press the Pepsi button, I need to get a Pepsi for sure, 100% of the time, all the time, 50 million years from now. Has to be the same. Consistency. Okay? So you may forget, you're probably gonna forget it. Don't forget it, but try to remember it, that multiple inputs and one output is a function. Because the coin, the start button, the button leads to one thing. That's multiple inputs, one output. Or if the vending machine doesn't have a slot for the coin, maybe it doesn't have a start button, maybe it's just a free vending machine someone put down the street, out of charity or something. You hit the button, you get an apple. That's still a function because an input, one output. That's how functions work with vending machines. Okay? Okay. Now, let's go back to the rule I showed you a couple minutes back. That definition of a function, the standard definition of a function. What does it say again? It says a function f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. What does that mean in terms of a vending machine? We'll get to the actual definition, all right? You'll understand the actual definition, but this is where it starts. Let's go over it again. A function f is a rule. Let's stop there. Function f is a rule. In our case now, the vending machine is that rule. A function f is a rule. Our vending machine, the whole vending machine is that rule. Because what does this vending machine do? It assigns each element x in a set A exactly one element in a set B. Okay? In other words, from all of these buttons, let's call them a group. From the group of these buttons, how many buttons? 1, 2, 3, 7 buttons. From the group of these 7 buttons, it doesn't matter which one you click, I'm thinking of computers now. It doesn't matter which one you press. Each button will give you only one element in a set B. So this is group A, the buttons. The items, Mr. Beast, Bad Bunny, Jeff Bezos, that's group B. Okay? One button in a set A, one element in a set B. That's all that thing is saying. That's all it's saying. One element in a set B. Now, let's forget about the vending machine for a couple minutes, okay? Now, let me drive it home. I think I'm going to drive it home with this point. Your social security number. Okay, now I'm not American, all right? But I think I understand a little bit how it works. A social security number belongs to one person only. If I type in your social security number, it does not matter how many people live in America. Even if there were 600 billion people living in America, if I type in your social security number into my laptop, your face should pop up. Not 2 other faces, just your face. So one social security number maps onto one person. Your fingerprint, one person. Your DNA, one person. Your DNA cannot have multiple people with the same DNA. Your fingerprints cannot have multiple people with the same fingerprint. Same with your social security number, only one person. Now, what's an example of something that's not a function? If I was your teacher and I came into class and I said, everyone who's age 19, please stand up. Is that a function? Is that an example of a function? No, it's not. It's not. Because I said, everyone who's the age 19, please stand up. Multiple people in a classroom can be age 19. So instead of one person standing up, 12 kids are going to stand up. That's not a function. Why? Because there's so many outputs. There's more than one output. That's not a function. But if I said, the person who has this social security number, please stand up. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever your whatever your social security number is, okay? You're the only one who's going to have it, so you're going to stand up. Now that's an example of a function. DNA, fingerprints, social security number, your cell phone number. Yeah, your cell phone number. If you give me your cell phone number and I dial it, it's going to ring at your phone. It's not going to ring your phone and your mom's phone and your sister's phone at the same time. It's going to ring your phone. Now, hopefully you answer me. If you're not going to answer me, bro, it's fine. You could just give me your sister's number. I know she'll answer. Hopefully. But it's only going to ring your phone. One cell phone number per person. Okay? I hope you get it. Tell me if you didn't. I'll try and explain it again. Okay, now, I have a trick question for you, okay? Is it possible that two buttons lead to the same item? Over here, I already drew it. We have our Coke button, the original one, and then I went and drew another one. So there's two buttons with the labels Coke on them. Would that still be considered a function? So what happens is, if I press Coke here, I get a Coke. If I press this Coke, I get a Coke. Is that a function? Yes, it is. I'll show you. Check this out. What did we say about functions? Okay, we said one input, one output. It doesn't matter how many times I press this Coke button, okay? I can press this Coke button 50,000 times. What am I going to get? A Coke every time. I can press this button 100 million times. What am I going to get? A Coke every single time. Yes, there's two buttons leading to the same thing, but it's still a function. Now here's an example with numbers now. What's 4 squared? It's 16. What's negative 4 squared? 16. Now how can that be? 4, positive 4 is not the same as negative 4. Those are different numbers. Yes, they have the same number 4, but one is positive, one is negative, so they're not equal. But if you square them, you get 16 for both cases. You see what I mean? Different numbers, but they give you the same output. It's the same thing here. Same thing. This button, I can press it 1 billion times, okay? 1 billion times. As long as this vending machine has Coke in it, someone stored Coke in there, I'm always gonna get Coke, man. I can press this one bajillion. Is that even a thing? Is that even a word? Bajillion times. It doesn't matter. I can press this bajillion times. Okay? What am I gonna get? Coca-Cola. Every single time. So what am I saying to you? Sorry, I'm covering the picture. I'm sorry. So what am I saying to you? I'm saying, take this vending machine, draw it in your scrapbook, and play around with it. It's going to help you tremendously. This picture, this concept I'm explaining to you now is the same concept I used to understand them. So I'm not teaching you garbage, right? This is the same, this Bad Bunny, Jeff Bezos, Beast, this is the same thing I used to understand functions. And that's why I'm teaching you, okay? So close the video. When you're done with the video, close YouTube, pause the video, whatever, all right? Grab your pencil and draw yourself a function, a vending machine, and then play around with them. Test your own understanding. See if you understand what a function is. Draw many buttons. Maybe you can even put a button that has no item in there. What happens then? That's a good question. What if I have a button for beer? A button for beer, but there's no beer in there. Is that a function? That's a good question. I'll leave that to you to think about, okay? That's what I mean. This vending machine, this concept I'm teaching here holds a lot of information. We haven't even gotten to the domain and range yet. This concept here is going to explain domain and range of a function too. So believe me when I say practicing with this vending machine concept on your own, in your time, testing your own knowledge, you're gonna grasp functions very, very good. Same thing I taught myself with, okay? Practice. Okay, now, we did our vending machine, okay? We have our Jeff Bezos over there, all right? What's something else that's intuitive? That's not a function. I mean, our vending machine is our function. We explained why it was our function. What's another machine that's not a function? A slot machine. When you go to the casino, you know the slot machine with the handle? I'll show it to you on the screen. I'll play a video for you now. But a slot machine is not a function. That's how they work. You're never gonna have a time where you put in a coin in that machine and you know exactly what you're gonna get. It's a casino, man. That's how they steal your money. You know what I'm saying? So there's never gonna be a time where you can for sure say, if I put in this coin and I hit that lever, I'm gonna win. You can't be sure because it's not a function. Okay, it can give you 3 watermelons in a row. And I don't know how these slot machines work, okay? But a slot machine in a casino is not a function. Whenever you get confused about functions, just think about those 2 machines. Just those 2, okay? A vending machine is a function. A slot machine in a casino is not a function. Think of those 2 whenever you get confused, okay? Because a slot machine, how is a slot machine different? I put in the coin. That's one input. I pull the lever. That's a second input. Now, what did I say a couple of minutes back? I said a function can have multiple inputs. Remember that slot for the coin? You put a coin there, you press the button, you hit the start button. Those are 3 inputs already. But if I hit the apple button, I'll get the apple. That's one output. That's a function. So yes, by putting in the coin in the slot machine, can we say it's a function? No, we cannot say. But can we say it's not a function? No, it's too early. It's too early to say that. We put in the coin. That's one input. So we're good so far. We're good so far. We pull the lever. That's a second input. We're good so far. We're good so far. We look at the screen. Oh, something we never predicted. Maybe we'll get lucky on a second time. We pull the lever again. Oh, something totally different. Maybe we'll get lucky again. Oh, different. We look in our pockets. We ran out of money. We got scammed. That's how casinos work, man. Okay. Slot machine, not a function. Vending machine is a function. Now, I don't want to leave that definition of a function yet. There's something in the definition of a function that I need to explain more, and I will do it in the next couple of videos. In the next video, I'll do it, okay? Let's go over the definition again. What does the definition of a function say again? It says, a function f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. Now, I don't want you to memorize it, okay? Eventually, you won't need to memorize it. Okay, and I don't need you to recite it. I just need you to understand it, okay? In the definition, I need to explain what f of x means. That f with the x, I need to explain that, and I will explain it in the next video. But I also need to explain that F thing, that what the hell that F thing means, okay? So if you didn't understand thoroughly in this video, that's okay. It's okay. We haven't gotten to the end yet. We're going to do that in the next video. That definition that we said in the beginning, I think you probably understand it to some degree, but I'm not done with the definition, okay? I'm still unsatisfied. I want to explain it in such a way that you leave the video, hey man, feeling like Superman. No, Spider-Man, who does this? Spider-Man? No, they both do it, isn't Superman also does this? Whatever, Spider-Man, all right? I want you to leave the video feeling like Spider-Man. So in the next lesson, in lesson 2, I'm going to delve deeper into the definition, okay? So this vending machine stuff, it was just an analogy, okay? So you get it intuitively. Now we're going into the mathematics, okay? We stop fooling around with Mr. Beast and Mr. Jeff Bezos. In the next lesson, I'll see you there. Cheers.